This massive machine behind me, the Giga press, is the heart of this facility's increased output.
Witness Giga, Texas, where traditional assembly lines are replaced by sheer hydraulic dominance. This is not just a factory, it is a fortress of metal, heat, and uncompromising engineering. Look at the Giga press, a two-story titan designed to crush old industrial standards. Gone are the 70 individual steel parts, replaced by a single massive aluminum casting. The process begins here, at the heart of the furnace, where raw aluminum turns to fire. Molten alloy, at 850 degrees Celsius, flows like lava through ceramic veins. Every drop is filtered, ensuring absolute purity before the high-pressure injection begins. Listen to the roar of the massive pistons as they prepare to lock the steel molds. A 350-bar hydraulic surge ensures the mold stays sealed against the void. In less than 100 milliseconds, the liquid fire is forced into the casting chamber. This is the intersection of medieval metallurgy and advanced aerospace precision engineering. Any microscopic air bubble trapped inside would mean a catastrophic structural failure. Steam erupts as the cooling system strikes, stabilizing the metal in a matter of seconds. The mold opens, revealing a masterpiece born from extreme pressure and zero tolerance. Observe the structural rear underbody, a massive singular component that redefines vehicular rigidity. The secret lies in the specialized aluminum alloy, a formula designed to skip traditional heat treatment. By eliminating heat cycles, we prevent the microscopic warping that plagues standard manufacturing. But cooling a piece this massive requires a brutal, precisely orchestrated thermal shock. Watch as the internal cooling channels within the mold engage, circulating water at extreme velocities. Thermal sensors monitor the temperature gradient across the entire surface every millisecond. Even a 5-degree variance could cause internal stresses, leading to invisible fractures. As the part stabilizes, a fleet of high-precision robotic arms move in with surgical grace. These Fanuc Titans are programmed to handle 600-kilogram loads with millimeter accuracy. The grip is firm but calibrated, ensuring no deformation occurs while the metal is still curing. Next, the component enters the trimming station, where high-power lasers slice through excess flash. The precision of a laser ensures a clean edge, ready for immediate integration into the chassis. Every scrap of removed aluminum is immediately recycled, fed back into the molten heart of the factory. This closed-loop system ensures zero waste, a hallmark of the Giga Texas manufacturing philosophy. Now, the singular casting is ready for the ultimate test, a high-speed structural integrity scan. The scanning chamber is where geometry meets digital perfection. Every micron is accounted for. Arrayed around the part, blue light laser scanners project a dense grid of millions of points. This point cloud data is instantly compared to the master CAD model by the factory AI. Any deviation beyond 0.5 millimeters triggers an immediate system-wide alert. We are looking for warping, shrinkage, or surface imperfections invisible to the naked eye. Beyond the surface, ultrasonic sensors probe the internal density of the casted aluminum. Sound waves at high frequencies travel through the metal, bouncing back to reveal any hidden voids. If a single air pocket is detected deep within the ribs, the entire unit is rejected. Next, the component moves to the stress test station, simulating years of road vibration in seconds. Hydraulic actuators apply cyclic loads, flexing the casting to its calculated elastic limit. This is the make-or-break moment, where the structural integrity of the single-piece design is proven. Under these extreme forces, the aluminum must behave as a predictable, unified entity. Watch the deflection meters. The movement is so subtle it is measured in the width of a hair. Once certified, the part is stamped with a unique digital twin ID for lifelong traceability. It is now ready to meet its counterpart, the massive front casting of the Giga Texas fleet. We are now at the convergence point, where the front and rear megacasts meet the structural battery pack. This is the unboxed methodology, building sub-assemblies in parallel to slash production time. Observe the central floor section, not just a frame, but a high-density energy storage unit. The 4,680 cells are packed with robotic precision, forming a honeycomb structure of immense strength. Unlike traditional designs, the battery pack itself provides the primary rigidity for the entire vehicle. A specialized structural adhesive is applied to the mating surfaces, stronger than any mechanical fastener. Massive overhead carriers lower the front casting onto the battery tray with sub-millimeter alignment. Automatic nut runners engage simultaneously, locking the heavy components into a single, unified chassis. Notice the absence of the traditional body-in-white skeleton. We are building from the inside out. This eliminates the need for robots to reach into cramped spaces, maximizing assembly efficiency. The seats are bolted directly onto the battery pack before the side panels even exist. This radical approach reduces the factory footprint by 40% while doubling output. Every connection is verified by high-speed cameras, checking the torque of every single bolt. The chassis is now a self-supporting, rolling stone of engineering, ready for the final skin.
This automated assembly line represents a significant leap forward in efficiency for the company. The chassis moves seamlessly towards the next stage of production.
With the structural core complete, we enter the phase of neurological integration. Thousands of meters of traditional wiring are gone, replaced by a centralized high-speed backbone. Watch the automated wire harness robots. They lay down the vehicle's nervous system in minutes. Every connector is gold-plated for maximum conductivity and resistance to the elements. Now, the exoskeleton panels arrive, cold-rolled stainless steel, unyielding and raw. There is no paint shop here. The beauty lies in the molecular strength of the alloy itself. Massive suction grippers lift the side panels, positioning them over the casting's hardpoints. Laser welding heads activate, stitching the steel skin to the aluminum core with micro-precision. This bimetallic bonding is a masterpiece of chemical engineering, preventing galvanic corrosion. The roof glass, a structural element in its own right, is lowered by a dual-arm precision robot. Observe the bead of high-viscosity urethane. It ensures a seal that can withstand hurricane-force winds. Internal climate control units are slid into place, fitting perfectly into the casted cavities. The dash assembly, pre-built on a parallel line, is mated to the chassis in one fluid motion. Every screen, every sensor is powered up for the first time, initiating the birth sequence. The machine is no longer a collection of parts. It is now a sentient industrial entity. We now move to the final assembly modules, where human-centric elements meet the titanium-strength core. Door assemblies, pre-integrated with windows and speakers, are snapped into place by precision hinges. The alignment is critical. A gap of more than 0.3 millimeters is considered a failure. Notice the steering yoke, a drive-by-wire system that eliminates the mechanical steering column entirely. Electrical impulses now replace steel shafts, offering a level of control seen only in fighter jets. The vehicle now reaches the fluid fill station. High-pressure coolant and brake fluids are injected. Specialized sensors detect any drop in pressure, ensuring the hydraulic systems are perfectly airtight. Then comes the wheel marriage titanium alloy bolts torqued to 400 Newton meters in seconds. For the first time, the machine supports its own weight on its active air suspension system. Every corner of the vehicle adjusts, calibrating its height to the factory floor with laser precision. Now, the lights are dimmed for the vision calibration. The vehicle's eyes are finally opened. Arrayed cameras and ultrasonic sensors are mapped against a digital grid for absolute spatial awareness. The onboard AI processes terabytes of visual data, learning to recognize every obstacle in its path. The vehicle is driven off the lift, moving under its own electric power for the very first time. It enters the hurricane booth, a brutal test of its elemental sealing under extreme water pressure. Beyond the deluge, the machine enters the dynamometer cell for a full-throttle powertrain validation. The dual motor system screams as it hits maximum RPM, generating thousands of Newton meters of torque. Energy flows from the 4,680 structural pack, discharging at rates that would melt standard copper wiring. Thermal imaging cameras track the heat signature of the inverters, ensuring the liquid cooling is flawless. Next, the vehicle is subjected to the torture track, a series of brutal bumps and high G turns. Listen to the suspension. The megacast chassis remains silent, devoid of the squeaks found in welded frames. This rigidity is the payoff. A single-piece structure doesn't flex, it dominates the road surface. Every shock is absorbed by the air ride system, reacting 1,000 times per second to the terrain. We now move to the acoustic lab, a room of total silence to detect the faintest mechanical whine. Sensitive microphones map the sound profile, ensuring the cabin remains a sanctuary of quiet power. Outside, the stainless steel exoskeleton is blasted with fine sand to test its abrasive resistance. No scratches, no dents. The molecular hardness of the 30x cold-rolled steel remains impenetrable. Even the glass is tested a high-velocity impact from a steel ball to simulate road debris strikes. The energy is dissipated across the structural layers, keeping the occupants encased in a safety cell. Certification is complete. The machine is now officially cleared for the global logistics network. The finished machine rolls into the outbound logistics hub, a massive subterranean terminal. Autonomous transport sleds move each vehicle to its designated bay with mathematical efficiency. Observe the scale, thousands of units ready for shipment, a silver sea of engineering excellence. Giga Texas is more than a factory. It is a self-sustaining heart of the global energy transition. The rooftop is a sprawling carpet of solar panels generating megawatts of clean industrial power. Internal recycling plants process every liter of water, ensuring a near-zero environmental footprint. This facility has shattered the myth that mass production must come at the cost of the planet. By consolidating the entire supply chain under one roof, we have eliminated thousands of tons of CO2. No more transcontinental shipping of parts. Raw material enters, the final product leaves. The economic impact is staggering, re-industrializing the heartland with high-tech manufacturing jobs. We are witnessing the birth of a new era, where the machine that builds the machine is the ultimate product. The lessons learned here at Texas are already being encoded into the DNA of the next gigafactories. From the 9,000-ton press to the structural battery, every innovation is a step toward the future. Engineering at this scale is no longer a challenge. It is a testament to human will and vision.
Are you ready to build the future? Visit our website to see how you can join the team at Giga Texas today.